Okay, welcome to Module 8, Process Surveillance. In this module, we're going to be touching on processes, malicious processes, and writing a script to automate and compare processes over time. So, to begin, we're going to be updating the package list because we will be installing some new tools, and we will be installing the following tools here. Okay. These are the tools that we're going to be requiring for this module today. And we will be beginning by running the command ESAUX. So this shows us the processes for all users. So we're just going to focus on this last line here. Just use it as an example of what you can see when you run this command. As you can see, all in all, we have a list of every single process that is running just now. So if we're to break down the lines, you will see username, process ID. This is the CPU usage in percentages, so it is used 1.6% of the CPU, 0.2% memory. You will also see the terminal that it is attached to. This is the state for the command, so R means it's running. We have the time that it was obviously ran, the start time. We have the amount of time the CPU consumed, barely any because it's a light command, and this is the command itself. So what we can use this command for is we can obviously see all the processes that are running, but we can also see malicious processes that are running. And how we can do that is that we can actually parse these results. So we're going to be using a command called watch. Watch basically loops whatever is in these quotations every 2 seconds. So it just keeps repeating it until we interrupt it with Control-C or any other means. So what we'll be writing in this, in these quotations, what we want to repeat is ESAUX, okay? That's what we're starting with. So we know this is going to now list the processes every 2 seconds. We're going to pipe that into grep-v grep, which removes grep from the output since we're going to be using grep to parse for something specifically. So then we're going to pipe that into grep-nc, so we can try and parse the processes for ones that contain nc in the command. The reason for this is because we want to try and catch a Netcat listener. Netcat is an extremely useful tool. We've used it in Bash for networking. However, it can also be used maliciously. You can use it to create a reverse shell, which is what I did in my first year for my ethical hacking module. But if you set up a listener, you can reverse shell into a machine and you can interact with it, you can execute different commands, you can create a new user, a root user that you could log into yourself, fully remotely as well, so that's quite dangerous. So if we were to run this, you can see we have things like, because these contain nc in the command at some point, they're going to show up. However, we're going to create a new window, and we are going to set up a Netcat listener. So to do this, you want to type nc-lvp and then the port number, which would, in this case, which is 24444. And we'll set that up, and you'll see there is a new process that has came up, the Netcat listener, and it's tied to terminal 1. If you'll remember from the start, we already touched on the fact that PSAUX was ran in terminal 0. This is terminal 0, this terminal here is terminal 0, and this is terminal 1, so we know it's in an external terminal. So a countermeasure to this is we can see here, this is the process ID, 3484. A countermeasure to this listener is we could come out and we could use the kill command and type in the process ID. Now, you'll see on this terminal, once we execute the kill command, the listener will end. So we have successfully deflected the listener. It is now no longer active. And if we were to check again, you'd see now the process is gone. You could run 2 terminals. You could run a terminal that watches the processes, and you could also run the kill command in a separate terminal. It's really up to you. You'll see it update every 2 seconds, so 2 seconds after we kill it, you'll see it disappear. Simple as that. Next, we're going to write a bash script that watches for any new processes that get created while it's running. So we're just going to create a new file, process scanner, give ourselves executable rights to the file. Okay. We're going to start with a shebang to tell the system that we're running bash to execute the script. And then we're gonna take our first capture of the processes that are currently running. So we'll call it original snapshot. And then this is going to hold the value of ps-e. Now, ps-e is the same as ps-aux. It just shows a shorter listing. You'll only see things like username, PID, time, and the command. You won't see anything else. So you won't see like CPU usage percentage or anything like that. We're sticking bare bones here. So we're then going to come down and we're going to create a new type of loop. We've already covered if statements, we've covered for loops, but this time we'll be making a while loop. So you're going to want to write while true do. Simple as that, similar to a for loop. So what this is going to do is this while loop is just going to loop forever until a certain condition is met. This one will be conditionless, so that it just keeps running and running and running and running until we manually tell it to stop by using Control-C. It's as simple as that. We're then going to come and we're going to write sleep 5. The reason we're writing sleep 5 here is not for flashy aesthetics, but because we don't want to overload the output. If we didn't put the sleep 5 and it just constantly kept updating, constantly, it would really overload things. We're then going to take a new snapshot. So we're going to just call it fresh snapshot. And we're going to do the exact same thing. It's going to capture the processes as well. So now we have the original and the fresh one, the new one. We're then going to come down and we are going to compare, because we need to see the difference between these two outputs. So to do this, you're going to use the diff command, and we're going to start by using the original snapshot, like so. And I'm sorry, I forgot the dollar at the start. So there we go. And we're going to come across again and do the exact same thing, but for the fresh snapshot. Okay, so now they're compared against each other. That's good. And then we're going to come down again, and we are going to make it so that the original, we're going to update the original variable. I thought I'm going to spell it there for a second. And then we're going to make it that this is equal to the output of fresh snapshot. And then we're going to come down and we're going to close it. Simple as that. So what this is doing is, once we run the script, it will first take an original snapshot of the processes that are currently running. Then the while loop will begin. And this will never be run again. This first line will never be run again. We're only going to run the stuff that's in the while loop over and over and over and over and over. It's going to wait 5 seconds, and then it's going to take a new snapshot 5 seconds after the original one's taken. So now we have 2 snapshots. We have the original snapshot and the fresh snapshot that's taken 5 seconds after. We're then going to compare those 2 snapshots to each other. We need to do that because we need to see what's changed constantly. Every 5 seconds we see what's changed. And then the original snapshot is set to fresh snapshot. So the original snapshot now holds the value of the fresh snapshot that was last run. And then we get a new fresh snapshot. Bear in mind, original snapshot now holds the value of fresh snapshot last time it was ran. And then we simply just compare them to each other again. It's as simple as that. Control O and then Control X to get out. And we'll just run it. And you'll see it will just capture processes and constantly compare them, fully automated. And we are going to run another Netcat listener, and you'll be able to see it pop up after each update. So you can see right now, you can see the PS command it keeps running because it's been running in the script. So we're going to set up another listener, and we'll just 5555. And you'll see right there in terminal 1, a new listener has opened. Simple as that. We can come back to the script. So Control-C to end it. If we go back to it, we can make it so that basically we can make it so it goes, we just create a file. We store the results in a file if we didn't want to run it in the terminal. So to do that, very simple. I'm going to come down, echo checking at, and then we'll just use the command substitution and put the date command in. Oops. Okay. And then we're going to append this to a new file called process log. Okay. And then simply we come down here again and we also append this to the same file. Okay, now why we're appending this is because we want to update the file, not overwrite the file. If this was one greater than symbol, it would put checking at and then capture the date and then substitute the date and then put it in there. So it would say checking at the 13th of July 2025. And then if we were to put one greater than symbol here as well, instead of appending the file, it would take the diff, it would compare the two, and it would erase the checking at date output, and it would just put a completely new output and overwrite the previous one. Appending just updates the file. So we'll constantly see checking at X time, and then we'll see the diff. Simple as that. So Control-O to save, and we will run it again for a short while, and then we will open the file, and we will have a little look at what is captured. Okay, let's go ahead and just end it. ls, and you should see the new text file that has appeared. We copy that and use the cat command to list the contents of that file. We can see, we have a look, we'll see checking at Sunday 13th July at this exact time, and we'll see the current processes that are running, and we'll see the comparison as well. And then it will run again, checking at Sunday 13th July, so this is 38, 33, so we can see the 5-second intervals between each capture, and you'll see it just constantly runs and it stores it in the text file. Again, appending is necessary so that the output grows, so we get more stuff in these files. We can even go back to the file and we could create a subdirectory to store the output of these files, and we could also input a timestamp variable so that we can have new files coming in each time we run this script. So we're going to come in timestamp, and timestamp is just going to hold the date. Simple as that. So now we have timestamp defined, and we need to make sure this is all outside of the while loop. We don't want this to be part of the while loop. We're going to create a new directory. Make sure to put -p so that if it doesn't exist, it'll make it, but if it already exists, it won't overwrite it. And we're just going to call it process scans. Simple as that. And then we're going to come down here, and we are going to, in this place, oops. And then we're also going to input timestamp variable into the file name. Simple as that. So now what we are doing is we are appending the process underscore log underscore whatever the time is, or sorry, whatever the date is, .txt. So it will go into the new directory and then append that file that is inside of that directory. It kind of keeps a clean home directory, keeps everything a little more manageable, and we know what files we want to, we can know what files we want to use because we can see the date that they were created. So it's just a little bit more handy, especially if you don't want to keep everything in your home directory because it can get pretty damn messy. So if we run this instead and let it run for a little while, and then we suspend it, list, we should see a new directory that was created. We can see process scans is right here. So we're going to change into the process scans directory, and we're going to get a list. And we can see our new text file that's been created, and it has the current date in the name. We used command substitution. Very simple. So we're going to copy the file name, and we're just going to cat it to see what it holds. And you can see, same thing again, checking at, and then the time, and it has checked processes and compared them as well. It is as simple as that. Thank you very much for your time, and I hope you learned something, and I'll see you in a bit.